Hi and Assalamualaikum, my name is AL-AMIN and welcome back to my presentation. So today I want to present my project Boolean expression calculator. So let's go to the slide. So guys, in electronic engineering, we often deal with very long and complex logic expression. Calculating this manually using K-maps or Boolean theorems is very slow and it is easy to make mistakes. So that's why I developed this Python-based GUI application to solve this problem. This tool automatically simplify logic expression into sum of product SOP or product of sum POS formats, making digital circuits design much faster and more accurate. So guys, before we go to the demonstration, I want to explain first about GUI component and program logic elements. So let's go. So now I will explain about GUI components. I built this application using the Tkinter framework to create a user-friendly interface and meet the project requirements. I integrate several key widgets. I use labels to display the title, instruction and the final result. For the user input, I included an entry field where user can type their expressions. I also use the radio button to let user choose between SOP and POS formats, and a button to trigger the calculation. All these components are organized using the pack method to ensure a clean and professional layout. So I will explain about program logic and programming elements. From a technical perspective, this application is built using an object-oriented programming OOP approach. By using a class-based structure, I can keep the code organized, modular and easy to maintain. The core logic of the calculator is handled by a dedicated function that integrates the SymPy library, which is a powerful Python tool for symbolic mathematics. This allows the programs to process complex Boolean algebra and perform advanced simplification that would otherwise be difficult to code manually. To handle the user requirements, I implemented conditional statements such as if, elif, and else. These statements are used to check the user's selection from the radio buttons, determining whether the output should be generated in sum of product SOP or product of sum POS format. This ensures that the applications make the correct logical decision based on the specific needs of the engineering problems. Okay, for the last, I add the error handling using a try except block. This is very important because it prevents the apps from crashing. If a user types something wrong or leaves the input empty, the program will catch the mistakes and show a friendly error message instead of closing. This makes the application more reliable and professional. By combining OOP, logical thinking and error management, this tool is ready for engineering tasks. So guys, now I will demonstrate the application in action. So first, I will insert the input A bar and B bar and D, or A bar and B bar and C, or A bar and B and D, or A bar and B and C. So I select the SOP and click the calculate. So we get the answer. So if I switch to the POS form, the results updates instantly if I click the calculate. This shows that the GUI and the logic engines are perfectly synchronized. Next, let's look at the error heading. If I enter an invalid input such as A and B, and I click the calculate button, a message box appears to warn the user. This prevents the program from crashing and ensure the smooth user experience, which is a key part of the programming requirements. So for the conclusion, this project successfully combined Tkinter with Python logic to solve a real-world engineering problem. Its function handle error correctly and makes Boolean simplification much easier. So that's all for me. Thank you very much for watching and see you for the next presentation.